Hey everyone, and welcome back to another Explainer. Today, we're breaking down the actual reality of network security, and more importantly, the absolute game changer that is artificial intelligence in this industry. Look, if you work in tech, or honestly, even if you just glance at the news, you hear about massive data breaches and system hacks literally all the time. But today, we're going to peek under the hood. We're going to look at what's actually happening on the front lines and how AI is completely rewriting the rules of the game for security engineers.
But first things first, I want you to just think for a second. What comes to your mind when you hear the word vulnerability? Do you instantly picture that dramatic Hollywood movie scene? You know the exact one I'm talking about? Some hacker in a dark room wearing a hoodie, furiously typing glowing green code to smash through a giant impenetrable firewall while red alarms blare in the background? Or maybe you picture a highly sophisticated multi-million-dollar Trojan horse deployed by a global syndicate.
Well, actually, the reality is usually way less cinematic. Having a vulnerability in your network is often just forgetting to lock your front door. A hack isn't necessarily about blowing up a reinforced concrete wall with high-tech digital explosives. Most of the time, it's literally just an attacker walking right up to your house, turning the knob, and pushing open a door that somebody forgot to lock.
To help us understand this massive shift, here is our roadmap for today's Explainer. 1. What is a vulnerability? 2. Types of network vulnerabilities. 3. Traditional vulnerability discovery. 4. How AI finds vulnerabilities. 5. Will AI become super hackers? And 6. The future of security engineers.
All right, let's jump straight into section 1. What exactly is a vulnerability?
So at its absolute core, a vulnerability is just a flaw. That's it. It's a flaw in how a system was designed, how a program was coded, or how a network was configured. It's basically an opening that lets an attacker slip in to access unauthorized data, execute malicious code, or even completely paralyze a whole system. And if you look closely, you'll notice what's at the root of almost all these flaws: human error. Whether a developer just wrote a bad line of code on a Friday afternoon or an admin slightly misconfigured a server, human mistakes are exactly what give attackers their opening.
Moving right along to section 2, types of network vulnerabilities.
There are really 6 main categories that we need to keep on our radar here. First up, operating system vulnerabilities. These are the deep, nasty issues like kernel bugs or buffer overflows in Linux or Windows that let a regular user instantly jump up to root access. Second, network device vulnerabilities. These happen in your routers, your switches, or firewalls, sometimes allowing remote code execution without the attacker even needing to log in. Third, web vulnerabilities, which are super common. Fourth, authentication vulnerabilities. Fifth, misconfigurations. And finally, supply chain vulnerabilities. This is where attackers get sneaky and hide malicious code in third-party packages, like Python libraries or Docker images, so a company essentially infects itself during a totally routine update.
Now, there's a really fascinating contrast between how we think hacks happen and how they actually happen in the real world. On one hand, sure, you have web vulnerabilities that require some serious technical skill, things like SQL injection, where an attacker types malicious SQL code right into a login box to bypass security, or cross-site scripting, which injects nasty JavaScript to steal user cookies. But on the other hand, look at authentication and misconfigurations. Guys, a massive chunk of real-world data breaches require absolutely zero technical hacking skill. Why? Because the password was literally just admin and admin, or a company accidentally left an Amazon S3 bucket or a Kubernetes dashboard totally exposed to the public internet. It's not some master hack. It's just a massive oversight.
Which brings us to section 3, traditional vulnerability discovery.
In the past, which feels like the dark ages now, security research relied on 2 incredibly painful methods. The first was manual code review. Security researchers literally had to sit down, stare at a screen, and read line after line of code. They'd analyze the logic by hand, just hunting for anomalies. As you can imagine, it was agonizingly slow and ridiculously expensive. The second method was using vulnerability scanners, tools like Nessus, OpenVAS, or Nmap. Those automate checks for open ports or bad configurations, which is helpful, but they have one fatal flaw. They can only find known vulnerabilities. If a hacker creates a brand new, never-before-seen bug, those traditional scanners are completely blind to it.
So to get around that blindness, researchers used a third traditional method called fuzzing. Honestly, fuzzing is basically just shooting in the dark. You start with a normal input, like typing the word hello into a search bar. Then you just frantically start feeding the program absolute garbage data. We're talking weird special characters, a million % signs, or insanely long random strings of text. You literally just keep throwing digital garbage at the wall until the system crashes. And when it finally breaks, boom, congratulations, you might have just found a vulnerability. It was a completely blind, brute force approach.
All right, Section 4. How AI finds vulnerabilities.
This is where things get wild. We are seeing a totally exponential jump in efficiency right now. In the past, a highly skilled human engineer grinding through a manual review might get through, 1,000 lines of code in a single day? Now, AI can process millions of lines of code, whether that's C, Python, Java, Go, you name it, in a fraction of the time. It instantly spots dangerous functions. Like if it sees a developer using a risky C function like string copy for a buffer input, the AI instantly flags it as a potential buffer overflow risk. It doesn't even have to think about it.
I absolutely love this analogy. When AI uses pattern matching to find a bug, it's exactly like a seasoned doctor looking at an X-ray to instantly spot an anomaly. See, the AI has been trained on tens of thousands of past historical vulnerabilities, what the industry calls CVEs. Because the model has seen so many past mistakes, the absolute second it looks at a new piece of code that structurally resembles an old vulnerability, it throws up a massive red flag. And hey, remember that blind brute force traditional fuzzing we just talked about? Well, AI upgrades that to smart fuzzing. Instead of just blindly shooting in the dark and hoping something breaks, the AI actually understands the code. It knows exactly where the software is most likely to snap, so it prioritizes testing those specific high-risk areas first, massively speeding up the process. On top of that, AI is incredible at anomaly traffic analysis. It continuously monitors all the system telemetry, the net flow, the data packets, and it detects weird logins or bizarre traffic spikes instantly. A lot of times, it catches a vulnerability before a human hacker even has a chance to exploit it.
Okay, moving to Section 5. Will AI become super hackers?
Let's just address the elephant in the room right now and break down this myth. Can AI hack? Well, partly yes, but it is nowhere near as exaggerated as sci-fi movies make it out to be. While AI is undeniably amazing at crunching massive data sets, finding hidden patterns, spotting anomalies, and reading endless lines of code, it struggles big time with complex business logic. It can't design a creative, multi-stage strategic attack, and it's frankly terrible at judging the subtle nuances of a target environment. It completely lacks that strategic, outside-the-box, intuitive thinking that a human expert brings to the table.
So the takeaway here is absolutely crucial. AI is a super assistant. It is not a human replacement. This isn't some Terminator coming to take over your cybersecurity job. Instead, it's the ultimate tool that's going to take all that tedious, repetitive, boring work right off the plate of human engineers, freeing them up to focus on the high-level strategy that actually matters.
Finally, Section 6. The future of security engineers.
So, what does this all mean for us? Well, the role of the engineer is fundamentally evolving. We're transitioning away from spending our entire week manually hunting for tiny bugs. Instead, the focus completely shifts. Engineers are now going to be tasked with verifying the results that the AI spits out, designing robust defense systems around those insights, actively applying the fixes, and building incredibly resilient overall security architectures. You aren't the bug hunter anymore. You're the manager of the AI's findings.
But there is a pretty stark reality check here. Whether you're a network engineer, a Linux admin, a Kubernetes expert, or a dedicated security pro, engineers who know how to leverage AI-assisted tech are absolutely going to outcompete those who don't, period. Learning to integrate AI into your security workflow isn't just some fun side project or buzzword anymore. It is quite literally an absolute must-have survival skill for the next decade of your career.
To wrap up this whole dynamic between humans and machines in the security world, I want you to just keep this one phrase in mind. AI finds bugs, AI fixes bugs, and humans make the rules. The machine is always going to do the heavy lifting, but human intelligence, complex logic, and strategic rulemaking, that remains the absolute beating heart of system security.
Which leaves us with a final, pretty massive thought to consider. In a totally new world where AI takes over finding and fixing all the bugs, are you ready to step up and be the one making the rules? The tools are already here. They are incredibly powerful, and they are changing literally everything about how we secure networks. It's time to start learning them. Thank you so much for joining me on this explainer, and I'll catch you guys in the next one.